Hi guys,
It's Maurilio,
and this is Davey, and this is our video. It's going to be a demonstration
for Chem.
and it's called the collapsing can. So let's get to it then.
Alrighty. Hey guys, these are our materials that we'll be using for the experiment. We have our container of water where we will be flipping our can with hot water in order for it to collapse. This is our can, obviously. This is our our ghetto measuring cup, which holds about ½ an ounce, which we will be putting into this can and heating it up over the oven. Normally we would be using a Bunsen burner, but we don't have one because we're in a house and not in a chem lab. And last but not least is our tongs, which we will be using to grab our can because it will be hot, and obviously you want to be safe. Also, normally we would have goggles, but today I have some designer goggles. And last but not least, for the second time, a lab apron. Thanks, guys.
So we're filling up the container with water, about 10 milliliters, and then we're just going to put in the empty can. Perfect. Okay, alright, we're going to bring it over, put it on the stove.
You guys think it's this one?
I got it, yeah. Just, yeah, just going to put it on there, and then we're going to turn it on. Okay, let's turn it on. Ooh,
there it is.
Okay, it's gonna heat up, and you're gonna let it sit until it boils. And of course, we will see it. Well,
I think it's already boiling.
We'll see, oh gosh.
Oh god.
We'll see it boil. Oh, yeah. We'll see it boil once we see steam coming out.
Looks like there's already steam coming out.
What the heck? That's impossible. Wait, we do see steam, but that might be the bottom of the can burning. So we have Maurilio doing, don't do this at home without, supervision. We're 17-year-olds, so, So, we have it boiling, and we're going to put it in this cold water.
Really? Did it work?
So, that sucked.
Got so much water and it didn't.
Well, that really sucks. Because we suck. Alright, so after waiting a few minutes, we're going to start to see steam. Well, you can't really see it on this. Let's see if you can. Yeah, well, it's there. It's hard to see through the camera. But, yep. Alright, so Maurilio's going to grab it. Make sure you get something to protect your hand because it's hot. We use catalyst to make the water colder, and ooh, and that's how you thaw strawberries, guys.
And collapse the can at the same time.
Well, let's
take it out.
Yep, take it out. It's not hot anymore. It just lost like all its heat, and if you notice, there's more water than we put in it. And we'll explain that to you in a second. Awesome.
Alright guys, so another aspect of this experiment is the catalyst. And so in this experiment, the catalyst is actually the water, which is speeding up the process of thawing happening inside the strawberries. Alright guys, so as you can see, this is a normal strawberry.
And so it used to be frozen like those, and now
as I eat one,
it tastes really good too.
it's not as frozen. Thawing.
And that's catalyst. Alright, cool. We're gonna just go ahead and do one more collapsing can. And let's see if it's ready. Alright, we're just doing it again. Shut off the fire so the house doesn't burn down. It's definitely hot, and here we go. Ooh, dang.
That was cray.
Whoa. It almost sucked in a strawberry, and there's definitely a lot of water coming out of there. And no ants. Yeah, so that was another collapsing can, and yep, there you go. Oh, is it recording? Hi guys, it's Mr. Selenium Xenon Yttrium here, and I'm just gonna go over and explain what happened downstairs with Davey and Maurilio. Davey was so nice to lend me his tank top for this talk. And so yeah, let's just get right into it. Explanation of what happened in the collapsing can experiment. As you guys saw, there was a can, of course, with this much water, you know, a little bit, and we got that to boil, or they got that to boil. My bad. They put it on a stove, got it to boil 100 degrees Celsius, 212 degrees Fahrenheit, whichever country you want to be living in for right now. And so basically they got it to boil, and then flipped it over, you know, and then it collapsed like that, and you all saw that. And so I'm just going to go over why that happened and explain it to you. So first of all, the water. Once we put in the water, it was just normal tap water, and once it started to boil, it turns into steam or water vapor, or whichever one you want to call it. And so that's what started to happen when it boils. We all know that. But actually, what was also happening is as that water vapor was leaving the can, there was only one hole where it could leave. So as it was escaping, it was actually pushing out air out of the can. And so the reason why the can, first of all, doesn't collapse by itself is because there's air inside, the empty can anyways. There's air inside, air outside. There's air pushing on it, there's air pushing against it from the inside and from the outside. 14.7 pounds per square inch. That's why we don't get crushed, because we're able to withstand that pressure. And so, but now you see air is starting to get pushed out by this water vapor. Hot gas is going to rise, and so, or hot air is going to rise, and so it's going to start. It started to push out the air as it started heating up and turning into water vapor. Now think about it. We have a can that used to have this much air, and now it's filled with this much water, and then it's filled with this much air because air is being pushed out. So from this much air to this much air. So now, if we think about the equation pressure and volume, since there's less molecules of air inside, there's going to be less pressure, and if the volume is constant, which it is. And so there's going to be less pressure inside the can. So what this creates is actually a low pressure vacuum. There's something that needs to fill up the can. And so what we did when we flipped over the can, the empty can with hot water in it, over into the cold water, the gas immediately condensed, and by doing that, it sucked up all that water. As you saw, when we lifted back up the can, all the water came out, and that's kind of the vacuum that was created. It had to suck up something, and since the only thing it could suck up was water, it sucked up water, and that's why there was more water than there was before. And so this instantaneous change in heat caused what was supposed to be gas to condense, and therefore it had to become less space per se.